All right, welcome to Slope, Scale, and Money. So we're getting close to the end of our learning content, and this is a bit of a mixed bag, but it's kind of fun. I think so. What are we looking at today? We're going to investigate slope, talk about different words that might mean the same thing or different things. We're going to look at scale drawings, how to find an actual measurement from a scale drawing, how to find the scale of a drawing, and different applications of that. And then we're going to talk about money, namely having done percentage before in 1510, we're now going to think more about discounts and how those work, or markups if you're going to sell something. And then I want to talk briefly about interest as well. Okay, so when I'm talking about slope, I'm talking about an angle, kind of. An incline. We're on an incline, right? And we're talking about how much it rises in a certain amount of distance. And we call that the rise, the vertical part, and we call the horizontal part the run. And the slope formula, and this goes for all math, is rise divided by run. So let's think about it. If we have something where the slope, we do that math and we get a slope that is greater than 1, what does that tell us? Well, that means the rise must have been greater than the run. Likewise, if we get something where the slope is less than 1, like a decimal, then it means the run must have been greater than the rise. Okay, so just recognizing that kind of stuff. And it's simple division. Now, if you want to talk about the grade, where you're saying it's a percent, then you are just going to multiply that slope by 100 to get the grade. So for our first example here, we had a slope of 0.5 when we divided 6, the rise, by 12, the run. So if I wanted to take that and get a grade, here's the math, 0.5 times 100, that's a 50% grade, which is pretty unmanageable. When we talk about pitch, which is something I see roofers do, basically, it's as if you took that triangle, that right triangle, that made your slope, but then you added a second right triangle. So instead of having the run, which is from here to here, now we have the span, which goes from end to end. So we're essentially doubling the size of our run. So our pitch is rise divided by span. So what would I expect if I was looking at this first example? Our run would turn into our span, which would be 24. Our rise would remain 6, and suddenly our pitch would be 6 divided by 24, which is 0.25, or 25% if we're thinking a bit more in the grade term. And that is mostly for roofing. I don't expect you guys to be using that. Usually when we talk about slope, you're just making that single right angle triangle. You can also talk about an angle of elevation. We're not going to do that in this course, but that brings in our trig thing. So if you ever want to find out what this little angle, we'll call it theta, that looks like an Easter egg, is, the math you would do, there's a button on your calculator, looks like this, rise divided by run, and that would tell you that angle in here, okay? Okay, so we're going to use staircases to think about slope, rise, and run. You're going to list your variables and see what you have to solve for. We've got some interesting here things we'll look at after over here that I thought were kind of fun. So when I look at question 1, I'm trying to find the slope. The treads are 8.5 inches wide, so that is your run. Just making sure you write down everything so you get it in the right place. And the riser height is 9.25, so that's my rise. And I know my formula. Slope equals rise over run. I'll write that down up here so that I have what I'm referring to. All right, and if we do that math, we get 1.09. So that's, and it doesn't have a unit because you divided inches by inches, so you canceled out your unit. Now looking at number 2, I know my rise is 8.25, and this time I have my slope, which is 1.05, and I'm looking for my run. So set it up again. Slope equals rise over run. Put everything in the right place. So I'm going to have 0.05 is my slope. And I know my rise is 8.25. And I don't know my run, so I'm just going to call that x, my unknown. So how am I going to solve this? I'm going to treat it like the cross multiplication trick, the magic banana. So I'm going to take my left side, I'm just going to put it as a fraction over 1 because that's not different. So remembering that trick, if you have two numbers that are kitty corner to each other, those are your multipliers, and you divide by the leftover. So here, if I want to find x, it's going to be 8.25 times 1, which, doesn't change anything, divided by 1.05. And then I will have my run is equal to 7.86 inches. Number 3. Once again, we've got a run is 9. Our slope is 0.9, and we're looking for the rise. Set it up. Slope equals rise, don't know it, over run, 9. So treat that as a fraction. Take your magic banana, it gets to go diagonally between the two numbers. So that tells you whether you're multiplying and dividing. Wait for this to catch up to me here. So basically, if I want to solve for x, I'm going to take 0.9, I'm going to multiply it by 9, and my leftover number was 1. Doesn't change anything. So I'm going to get a rise of 8.1 inches. Okay, and kind of a neat thing I saw when I was researching this is the rules of thumb for stair building. And I've got a lot of terrible stairs in my house, so this was interesting to me. So if you want to make stairs, you shouldn't exceed 8.25 inches high. You should be at least 9 inches across. And then there's this neat thing, if you multiply the two values together, you should get something in the range of 72 to 75. Okay, so let's see if anything follows these guidelines. So we have a rise of 9.25, which is too high. We have a run of 8.5, which is too short. And if we do the rise times run, we're going to get 8.5 times 9.25, which is 78.63, which is also no good. Let's look at number 2. Our rise is 8.25. That's okay. Our run is too short. And then if we do the rise times run for number 2, we get 7.86 times 8.25, which should give you 64.84. And the last one, our run is 9. That's okay. Our rise is 8.1. That's okay. And if we do the rise times run, we are going to have, well, where'd it go? I wrote it down somewhere there, 72.8, which is okay as well. So of the 3 staircases I just built, the only good one is here. And I should have known that because when I look at the max rise, which is the highest I can get, and I divide it by the minimum run, so this number can go down on top and the number on the bottom can get bigger. So that, when you divide, that makes a slope of 0.92, which will be the maximum slope we would ever produce. And our first 2 staircases had the wrong slope anyway, 1.09, 1.05. Those were too high. Am I going to quiz you on rise and run of a staircase, like the stuff in the green here? No, but I do expect you to be able to take a slope, a rise and run, any 2 of those, and find the 3rd measurement. Moving on to scale drawings. So when you have a drawing and it's got a scale on it, you'll see 2 numbers. And sometimes they'll have units, sometimes they won't. We'll talk about that in a sec. The first number is always what you see in front of you on the drawing. And the second number should always be the actual size. Okay, so, or the actual comparable units in real life. So when we look at these 3 things I've drawn here, my question is, which scale would be used for drawing a house? Well, if I took 1 and on my drawing, so say 1 centimeter on my drawing is 50 centimeters in real life, that's feasible for a house. And which scale would be used to draw something microscopic? Well, if I had 20 centimeters on my drawing and it represented 1 centimeter in real life, that's something that's smaller than your drawing. So I'll call that microscopic. Maybe the crapping one. And then this one is when you draw something actual size, right? 1 unit on my drawing is equivalent to 1 unit in real life. Okay, so before we go into this, we talk about scales, and they can be ratios or rates. So by definition, a ratio is the same unit. So your drawing, if it's in millimeters, and your actual will be millimeters as well. Okay, and that's a ratio. Okay, so generally metric scales are ratios, and then you don't have to see a unit because it should be understood that they're the same unit. So those are the ones that shouldn't have units. Sometimes the US customaries also don't, which bugs me, because the US customary ones are generally rates, which is you have 2 things that are equivalent, but they're not the same measurement. So you might see a 1/4 inch on your drawing is equal to 1 foot in actual space, or you might see something like 1 inch on your drawing is equivalent to 8 feet. So for those rates, they're both scales, one's a ratio, one's a rate. I want to see units in there, and I'll make sure that I give units because that's only fair. And we're going to do a couple more examples here. So we have a map, and it's metric because I see no units, and they often have ridiculous scales that look like that. That is fun. Okay, so let's set up our scale. Make sure I get the right amount of zeros. Okay, and I'm just going to leave it as kilometers. I mean, there might be something to be said to change it to meters or even something else, but I'm just going to leave it like this. So the actual distance is 112, so I'm looking for the distance on the map. Okay, so setting that up properly, and go back to that kind of table if it's hard for you. So here, the 2 numbers kitty corner are our multipliers, so I'm going to have x is equal to, I'm dropping the 1 because it's kind of obvious. All right, and suddenly I get x is equal to 0.000224, and that's in kilometers because we keep the units we went in with. Okay, that's not particularly useful to me, so I'm going to start changing it. So if I divide by 1,000, or sorry, multiply by 1,000, I'll get meters. Also not super useful if I'm looking at a piece of paper, and if I, let's say, multiply by 100, I'll get centimeters. Okay, so how far apart are they in the map? 22.4 centimeters. Looking at number 2. So I'm looking to find the scale. I've been given some information and I'm looking for the scale. So it says, I know that the master bedroom is 12 feet by 20 feet. So that probably, here's the master bedroom. So the 12 foot would be here and the 20 foot would be here. And you can use either of those comparisons to solve this. So this time I'm looking for my scale. So I know that in real life we have 4 feet. And on the drawing, we're going to have some number. And I'm going to use the 20-foot one. So I see that to make 20 feet, I have 1.25 inches. And I'm going to figure out what the scale, missing number in the scale is. So here's my multipliers. And now because I don't have a 1, just don't drop anything. So x is going to be 4 times 1.25. And then you always divide by the leftover number. And when you do that, that should give you 0.25. So basically, that means I know that my scale is 0.25 inches, which is 1/4 inches, to 4 feet. Okay. And now if they want me to replace the drawing dimensions with actual dimensions, I can use that scale to solve for anything. So if I look at, well, this one will be 12 feet, and the only one I'm wondering about is that. So I'm going to set up my scale again over in this corner. If 0.25 inches is equal to 4 feet in real life, then 1 inch equals what? So we're going to do 1 times 4 divided by 0.25, and that should give you 16. So there's your last dimension. Here we have a map of Algonquin College, and there's something that can be said. And when I did this, I printed this out and did it on the actual piece of paper. So when I did it, I'll tell you the numbers I got. So I see down here, whoa, come here, I have my scale. So what I did is I just measured that because I didn't know how far that would be. And when I printed it out and measured it, that distance happened to be 11 millimeters. So I've kind of got a scale which is 11 millimeters, and it's going to be, I'm going to put the units in because we're not a ratio or a rate, and that's it. So now here's my question. I usually end up parking, back in the days when I went to Algonquin College in person, over by the vet by the time I get to work. And often I end up teaching in the CA building right about here. And I'm going to draw a line in between those, hopefully with some kind of skill. Maybe not, bear with me. Okay, so we're going to start here. It's not going to work for me. Okay, unfortunately you're now going to have to experience my terrible line drawing. All right, so straight line. No, everything's been eaten alive. Okay. There we go. There's my straight line. Okay. And I want to say, in theory, if I was walking from my parking spot to my classroom and I was able to just bulldoze through in a straight line, how far am I walking? Okay, well, what are you going to do? You're going to take your ruler. I already used the ruler to determine that this little piece down here, my scale from my legend, was 11 millimeters. So I'm going to measure the length of this line in millimeters. And if I do that, when I printed it out, and honestly, you could do it on your computer screen too, I get 106 millimeters. So here we go. My scale is 11 millimeters equals 100 meters. I measured 106 millimeters, and I want to know how far I'm walking. Same old, same old. X is going to be equal to 100 times 106 divided by 11. And when I do that math, I get about 964 meters, which sounds about right and is insane. I'm walking almost a kilometer to get from my parking spot to my classroom. Now we're going to switch over to money. And we're going to talk about when you buy something and when you sell something and when you owe people money. So when you're a contractor, you usually have a discount with your supplier. So those can compound and get complicated, and it's not really intuitive how you calculate them. So things that we should consider: that we always apply discounts before we do our tax. So on something that's called the subtotal, either for the total bill or for individual items. We have something we call the complement. So if you had 25% off, that was your discount, and then we know that you are going to pay 75%. So that's it. So the complement basically is 100% minus your discount. And we're going to use that to do chain discounts and stuff like that. And it's also good to know that it's very involved calculating multiple discounts, but there's a cheat where you can just do chain discounting and do all the math in one swoop. Okay. So let's see how that looks. Okay. So I'm going to buy, and I'm going to highlight my relative information. And I'm assuming you guys remember a few things about percent already, so I'm kind of skipping over that. Okay, so I see this kind of thing. So the wrong way to do this is to think, oh, if I'm going to get 25% off and then 6% off, I'm going to get 25 plus 6 equals 31% off. And then proceed to do your math. If I want to find that, you're going to switch your percentage into a decimal. And I want to know the amount I pay. So if I want to do math that way, I do. And remember, I'm doing the wrong way right now. but there are some valid things. I'm going to pay 69% of the total price. So if I want to figure out what I pay, I take my original price, $359. I'm going to pay 69% of that, and I'm going to pay $247.71. This is not correct. Okay, you have to do your discounts in steps. So let's say we're going to have discount 1, which is 25%. Okay, so I know that it's going to be 1 minus 25% as a decimal equals 0.75. So there's my first complement. So in order to apply my first discount, I do this math. And I basically end up with a new base, like a new price. And that's what I apply my second discount. And this is why the first way doesn't work, because you have to kind of reset your base and reapply the next discount to your new price. So I'm going to apply discount 2. And I see it's going to be 6% off. Careful with your conversion. So I'm going to pay 94% of that 269.25, and let's apply that one. So what am I going to pay? $253.10. So you never get as quite a good a deal as if you could apply it all at once. Okay, so another thing, if I'm thinking about the actual discount I got, it wasn't, I know it wasn't 30%, but what was it? You can do it a couple of ways, but you can also do it just by taking those two complements. And this will lead into our chain discounting. So the 75% you paid on the first amount, and the 94% you paid on the second amount. And you get, when you multiply them together, this, which means you paid 70.5% of the original price, which is slightly different than paying 69% of the original price. So it's weird, just bear with me. Here's the idea. This is just an accounting slide I stole. So the idea here is that you start with a list price and you do your first discount. So here they've done the subtraction. I'm lazy. If I want to take 20% off, I'm going to go, the new price will be 600, 80% of 600, which is going to equal this 480. And then if I want to apply my second discount, I'm going to do that 480, and I know I will have the complement, which is 95% because of 1 minus 0.05, and that will get me to this answer. So here's what you can do. If you want to apply a chain discount, you can start with your list price, and then you just multiply by all the complements, because that will reset in the math. So if I want to apply the first one, it's 20% off, so I'm going to pay 80%. If I want to apply the second one, it's 5% off, so I'm going to pay 95%. And that will get you right to that $456 without kind of redoing. So let's look at it. So here's a crazy one. So we have an online store. Our first discount is 15%, then we do 30%, and then we get 8% off. And our original price was $237.50. So if you were doing like kind of supplier stuff, you might see this written as 15, 30, 8, which is all the discounts that you're going to get, those kind of chain discounts. So let's think about what those discounts are. So for discount 1, I get 15% off. So 1 minus 15%, we're switching to decimal form. So my first complement is this. For discount 2, I get 30% off. So that's 0.7 for the complement. And for discount 3, I get 8% off. So working in decimal form, make sure I've left that decimal in there, 0.92. Okay, so if I want to know how much these are going to cost after all these discounts are applied, my list price, and I'm just going to multiply by all those complements. Oops, 70. And it should be $130. There we go. Okay, what total percentage discount did you get off the original price? So let's find out how much we paid, what percent of the price we paid. We're going to multiply all our complements together. Oh, I really want to make that 75. And I get 0.54754. So this is what I paid. This is not my discount. So my percentage discount, I'm going to just subtract that from 1. And I get 0.4526. And if I want to know that in actual percent, multiply by 100. And my discount was 45.26% off. And if I had just added up these three numbers, it would have seemed like I should have got 53% off, which I didn't. Okay, so those chain discounting saves the company that's selling things to you a little bit of money because you're not getting as good a deal as you might think you are. Still a smoking deal. So let's sell some stuff now. So whenever you buy something, you are going to mark it up. So if you manufacture something, you're going to put some markup in above what it cost you to produce. If you're the middleman, the wholesaler, definitely going to buy low, sell high, and the retailers will also mark up. So things get really expensive over the course of their consumer life. Okay, so we're going to treat this like discounting. We're going to do the markup percentage into our calculations, and we're marking up based on that subtotal. We don't include the taxes, although I will add taxes into these questions afterwards. So no different. The easiest thing to do, let's say we have a 25% markup. This time you're going to take the 100%, that was the original price, and you're not going to subtract it, you're going to add it. So when you do math with a markup like this, it's 125%, so you're going to use 1.25 in your calculations, just that decimal percentage. Okay, so a very simple example. There's our $359 faucet, and I'm going to resell it for 30% markup. So I take my $359, and then I'm going to sell it for 130% of my original price, right? 100 plus 30 equals 130%. So when I put that in decimal form, 1.3, I haven't asked for taxes, so you're just going to do this simple math, and you are going to charge your client for $66.70. So here we go. Okay, so just highlighting the relevant information. I paid this, so that's my original price, and I'm going to mark it up 25%, and then I'm going to add tax on. So that's going to be 13%. So basically I have a markup 1, which is 1.25, 125%, and then I have a second markup, which is 1.13, which is just us adding in our taxes, but I'm using it like a max markup. So if I want to figure this out, I don't have to do it in steps. I can just simply take my original price and apply one markup and apply the second markup. And that's going to tell me that we get 224.69. Okay, which is higher than if you had just done a 38% markup on this original thing. It always works out this way. And the nice thing about markup is that if you're the one selling it, you're going to make more money. Same if you are discounting it, you will never, people will not get the deal they're thinking they're getting. If you're marking up, you're making more. Okay. So here's just kind of what if I'm asking you for the markup. So just kind of using always those ratios. So I want to know how much the percentage markup is. So let's say I have this tub and I bought it for that. And I know that's 100% of the price. And I'm going to sell it for this. And I love ratios for all this because it just is a way to talk through and make it easy. And I want to know what 2,500 is relative to 1,575, because 1,575 is my starting price, so that's always your 100%. So once again, we're going to magic banana this, and we're going to find out that X is going to be, the yellow guys get to multiply, the leftover divides every single time. So X is going to be 158.7. So what does that mean? If we had 100% and we're selling it for 158.7%, our markup is 58.7%, okay? So the original 100% plus a 58.7% markup. Okay, let's look at the second one. We've got a $50 part, there's an 80% markup. We're also gonna sneak in a 15% exclusive item charge, and then we're gonna add taxes. So here we go. Markup 1 is 180, so 1.8. Markup 2 is 1.15, that 15% exclusive thing, and our markup 3, or just incorporating our taxes. Okay, here we go. 50 times 1.8 times 1.15 times 1.13, and that gives you $116.96. And if we look at that and we want to find out what that markup actually was, we would have just done multiply our complementary things, and that would have given us 2.34, which is 234%, which means that we have to subtract the original price. So our markup on the original actually ended up being 134%. And if you had added these three numbers in, the 80 and the 15 and the 113, wouldn't have been nearly as nice. Would have been 108%. So it always works in your favor. All right, I want to talk about interest charges. I'm not going to test you on this because it's not in your course outline, but I think it is one of the things I really like to hammer home, especially with my tradespeople, because there's so many people who want to just sell you a tool off the Snap-on truck and don't worry about it, don't worry about it. We'll figure it out later. So let's talk about what happens with interest on credit. Okay, and if you're using a credit card, you're paying compound interest. There's no simple interest unless you're borrowing money from your grandma. It just doesn't really exist in real life anymore, except for family loans. Okay, so I'm gonna put $5,000 on my credit card for some awesome tool, and then I'm gonna forget to pay, and I'm gonna see what happens. So let's talk about it. This is the formula. I'll walk you through it. Okay, so here is gonna tell me what I owe after 2 months. My original thing was $5,000. My interest during the compounding period. Now, these are monthly, so interest is compounded monthly. So when you're doing this, you're going to think about how much you have to divide something for. Sorry, I've got some background noise. So I'm going to have that interest, which I put in decimal form. And if I have 12, that's an annual one, but I need to split it into a monthly one, so I'm going to divide by 12. So it does get a bit smaller, the number at least, but it's still going to be pretty terrible. So I'm going to pay this much interest, 1.67% in 1 month. Okay, and I said I was 2 months late on my payment. So here, everything goes into the formula. My amount I put on my credit card, I'm going to do 1 plus that 0.0167. And it's going to be for 2 months. Okay, so order of operations, you do the squaring first. After we already did the brackets. Okay, 5, 1, 6, 8, 39. So there we go. In 2 months, I have gotten already $168.39 in interest. So it goes quickly, and my next month's interest will be calculated not on the original $5,000 but on the new amount, so on $5,168.39. So it's folding that interest in, and you're accruing debt much faster than you would with simple interest. So the other thing that makes me laugh about this is if you ever look at your credit card statement, it says the minimum payment is always $10. So that's awesome. So if I were to run it for 1 month, let's say, my formula becomes same numbers, but I've only done it for 1 month. So it's just basically multiplication. And after 1 month, I'm going to owe, but they tell me I only have to pay $10. So I'm going to owe, oh my goodness, this much. All right, so I've tried to turn it off for a minute to let the crazy recede. That's what I owe after 1 month if I make only the minimum payment. So what happens in the second month, I take my new, not significantly smaller amount, and I still have to apply that same interest rate, and I still am increasing quite a lot. So, now I owe, after 2 months, I've got $158.23 interest. If I pay the minimum 10 amount again, it's really not going to help you. You're going to rack up debt pretty quickly. So what's my advice? Pay off your credit card every month. So when those 30 days are up, you better be able to pay off the entire balance, or else you're just getting so far behind.